Hello class, today we are continuing with chapter 8, personal finance. We're going to look at 8.6, which discusses cars. Now we'll look at several different objectives when it comes to cars. So we're going to learn how to compute the monthly payment and interest cost for a car loan. We're going to compute the monthly car payment for a car loan using a spreadsheet. We're going to understand the types of leasing contracts. We're going to understand the pros and cons of leasing versus buying a car. We're going to understand the different kinds of car insurance. We're going to compare monthly payments on new and used cars. We're going to solve problems related to owning and operating a car. Now, let's look at the mathematics of financing a car. A loan that you pay off weekly or monthly payments for, or payments in some other time period, is called an installment loan. The advantage of an installment loan is that a consumer gets to use a product immediately. The disadvantage is that the interest can add a substantial amount to the cost of a purchase. Let's begin with car loans, in which you make regular monthly payments called fixed installment loans. So, we're going to look at the loan payment formula for a fixed installment loan. The regular payment amount, your PMT, required to repay a loan of P dollars paid N times per year over T years at an annual rate R, is given by PMT equals P times R over N divided by 1 minus 1 plus R over N raised to the negative NT. Now, I believe we've seen this formula before. It should start to becoming familiar. So let's take and look at an example. So we're going to compare car loans. We're going to give you two different car loans at two different rates and at two different year installments. And we're going to see how different they are. So suppose that you decide to borrow $30,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. Installment loan A is a 4-year loan at 3%. Installment loan B is a 6-year loan at 4%. Now, we want to find the monthly payments and total interest for loan A, and we want to find the monthly payments and total interest for loan B. We also want to compare the monthly payments and the total interest for the two loans after we calculate them. Now, what's important to see here for part A is we're finding the monthly payments and total interest for loan A. All right, we're going to use the formula that we just went over, the PMT formula, but we're going to need the P, the R, the N, and the T. So let's go back here and look. Now, our P here is going to be the $30,000 directly from the problem. The R for installment loan A is 3%, better written as 0.03, because we have to write it as a decimal to use it in the mathematical formula. The loan amount here is a 4-year loan, and we're paying this 4-year loan monthly, which means 12 installments throughout the year. So we have everything we need to substitute within the formula. The P is 30,000 times 0.03 over 12 divided by 1 minus 1 plus 0.03 divided by 12 raised to the negative 12 times 4. Okay, the 12 just comes from the month, the 4 comes from how many years, the 0.03 is our rate, and the 30,000 is how much we're borrowing. Once we calculate that out, we see that that equals approximately $664. So our monthly payments are about $664 for loan A. So let's calculate what the interest may be. Now remember, the interest is the total amount paid for the loan minus the vehicle original value. Okay, the vehicle original value here is $30,000. We got that directly from the problem. But in order to calculate how much we actually paid for the loan, what we have to do is take our monthly payment, which is $664, and multiply it by the number of payments we had. Now, where does that 48 come from? Well, we're paying this loan over 4 years, and we're making 12 payments per year because there's 12 months in a year, and we're making one payment per month. So 4 times 12 is what gives us the 48 in our formula. We're making 48 payments of $664 to pay off this loan. What winds up happening when you do the simple math here, the multiplication and the subtraction, is that you see we have an interest amount of $1,872 that we pay when we do our installment loan as loan A. Okay, let's see how that changes for loan B. Because if we go back here and look at loan B Loan B is a 6-year loan at a higher rate of 4%, which is typically what happens. The longer it takes you to pay back a loan, typically the higher interest rate they're going to charge you. If you do a short-term loan, typically you get a better interest rate. Typically, not always, but typically. So let's calculate this for loan B. Same formula. P is still $30,000 because the vehicle still costs that much. We're looking at a 4% interest this time. That's why we get times 0.04 divided by 12 because we're still making monthly payments. Divided by 1 minus 1 plus 0.04 divided by 12, still from the months, minus 12, still from the months, times 6 because now we're paying it over a 6-year period instead of a 4-year period. When we multiply all that out, we see that our monthly payment has now dropped to $469. So monthly payments for loan B are about $469. The interest for loan B, we need to calculate. Okay, and you can see it calculated there, but you're going to ask me, where did the 72 come from? Remember, we calculate the amount of payments. That's essentially what that 72 is. We do our monthly payments times the number of payments to get the overall amount paid for the loan. So here, 469 times 72, the reason we multiply by 72 is we've got 6 years that we're paying over, and there's 12 months in each year, and I'm paying once a month. So 6 times 12 is where that 72 comes from. That's the number of payments that I'm going to have to make for loan B in order to pay this vehicle off. Now what we see is, once we find that and subtract it from $30,000, that we wound up paying $3,768 in interest for this loan. So while the monthly payment was cheaper, we paid more in interest at the end of the loan than we did for loan A. Now let's set it up and look at it in our chart here. So we've got a $30,000 loan with a monthly payment and the total interest. So we know that the 4-year loan at 3%, we had a higher monthly payment of $664. Versus the 6-year loan at 4%, we had a monthly payment of $469. So 6-year loan does have a smaller monthly payment, but when we compare the interest of the two loans, we paid less interest with the 4% or for the 4-year loan at $1,872 versus the 6-year loan at $3,768. So interest is more with the long-term loan, but the monthly payments are less with a long-term loan. So you really have to balance what you can afford. If you can only afford to make a smaller monthly payment, then sometimes you have to go with a longer-term loan, and you do wind up having to pay more interest over the term of the loan. But if you can't afford the higher payment, that's sometimes a decision you have to make. Let's look at the leasing alternative. Leasing is the practice of paying a specified amount of money over a specified time for the use of a product. Leasing is essentially a long-term rental agreement. A close-ended lease is when each month you make a fixed payment based on estimated usage. When the lease ends, you return the car and pay for mileage in excess of your estimate. An open-ended lease is where each month you make a fixed payment based on the car's residual value. Now, the residual value is the estimated resale value of the car at the end of the lease and is determined by the dealer. When the lease ends, you return the car and make a payment based on its appraised value at the time compared to its residual value. If the appraised value is less than the residual value stated in the lease, you pay all or a portion of the difference. If the appraised value is greater than or equal to the residual value, you owe nothing and you may receive a refund. Now, there are some advantages and disadvantages. Let's look at some advantages. Okay. Now, leases require only a small down payment or no down payment at all, but I will tell you that when you buy a vehicle, there are cases when you can buy a vehicle instead of leasing a vehicle and still pay either a small down payment or no down payment at all. So while that might be an advantage with leases, it is also an advantage with buying a vehicle in many instances. Not every instance, but many instances. You can buy a vehicle with either a very small down payment or no down payment at all, depending on your credit score. Now, let's look at advantage number 2 for leases. So lease payments for a new car are lower than loan payments for the same car. Most people can lease a more expensive car than they would be able to buy. Okay. When the lease ends, you return the car to the dealer and do not have to be concerned about selling the car. Okay. So those are some stated advantages based on the textbook. Now, let's look at some disadvantages. All right, disadvantage is when the lease ends, you don't own the car. So you have nothing to show for all that money you paid for over that time period. Okay, you do not own the vehicle after the end of a lease. Most lease agreements have mileage limits. 12,000 to 15,000 miles per year is common. And if you exceed the number of miles allowed, there can be considerable, I'll restate that, considerable charges. When mileage penalties and other costs at the end of the leasing period are taken into consideration, the total cost of leasing is almost always more expensive than financing a car. While leasing the car, you are responsible for keeping it in perfect condition, and you are also liable for any damage to the car. Leasing does not cover maintenance. So the maintenance of the vehicle is not covered by the lease. And there are penalties for ending the lease early. Okay, so keep those in mind if you are thinking about leasing. While there might be some small advantages, there are many disadvantages as well. So if you are looking into the car market, please be aware of the disadvantages of leasing. Let's also look at auto insurance, something that is required when you have a vehicle. So when you purchase insurance, you buy protection against loss associated with unexpected events. Different types of coverages are associated with auto insurance, but the one required by nearly every state is liability. Now there are two components to liability coverage. Okay, the first component is bodily injury liability, and that covers the cost of lawsuits if someone is injured or killed in an accident in which you were at fault. There's also property damage liability. That covers damage to your car or to other cars and property from negligent operation of your vehicle. So it doesn't cover yours, it covers damage to other cars and property from negligent operations of your vehicle. Okay, you've got collision coverage that pays for damage or loss of your car if you're in an accident, and you have comprehensive coverage that protects your car from perils such as fire, theft, falling objects, acts of nature, and collision with an animal. So let's look at example 3. Example 3 says saving money with a used car. Suppose that you are thinking about buying a car and have narrowed down choices to two options. A new car option. The new car costs $35,000 and can be financed with a 4-year loan at 2.9%. The used car option is a 3-year-old model of the same car and costs $24,000 and can be financed with a 5-year loan at 3.6%. What is the difference in monthly payments between financing the new car and financing the used car? So let's determine the monthly payments for the new car that costs $35,000 financed with a 5-year loan at 2.5%. Just restating everything that's in the question. So we're going to use that formula we've been using, the PMT formula here. All we're going to do is substitute these values in. So we're substituting $35,000 in for P, multiplying that by our rate here, 0.029. That's our rate for our 5-year loan, divided by 12, divided by 1 minus 1 plus 0.029 divided by 12 raised to the negative 12 times 5, because we are doing, for the first one, a 5-year loan. Okay, that should equate to $627 a month. That's your payment per month right there, $627. Okay, that is for the new car option. Okay. Now let's look at the used car option, because the used car option is a 3-year-old model of the same car and it costs $24,000. So alternatively, we're going to determine the monthly payments for the used car that costs $24,000 financed with a 5-year loan at 3.6%. So using the same formula, but substituting these new values in. So this used car costs $24,000, and we're going to multiply that times 0.036, because that 5-year loan is at 3.6%. Right there from the problem. All right, we're going to plug that in. Divided by 1 minus 1 plus 0.036 divided by 12 raised to the negative 12 times 5, because this one now is a 5-year loan. Okay, That gives us approximately $438 a month. So the monthly payments for the used car are approximately $438. The difference in monthly payments between the new car loan, $627, and the used car loan, which is $438, if you subtract those values, you see the difference is $189 per month. Okay, so for $189 per month more, you can have a new car. Or for $189 less, you can use the used car option. Now, before I continue, something to think about here, and I'll just mention this briefly. Something to think about here. One, you have to think about your financial situation, obviously. So if you can't afford the $627 per month, that automatically eliminates that option. And maybe you can afford the $438 a month payment, and that makes that more viable. But you also have other variables with buying used cars versus new cars, because new cars usually come with warranty, and much better warranty than used cars. You can also purchase extended warranties. They'll call you about that, I promise. But typically a new car is going to come with more options than a used car will when it comes to things like that. So just be careful as well. A new car is obviously new and it hasn't had anybody driving it, so it has no history attached to it. A used car, while it may look to be in good shape, might not necessarily be in as good a shape as it seems. I like to say you never truly know what you're getting with a used vehicle. You can have some good expectation with a new vehicle. But financially, sometimes you financially have to go with what you afford. I've bought myself new vehicles and I've myself bought used vehicles in the past, and there's pros and cons to both. But in example 3, we're just looking at it strictly financially for the payment of the car, not the reliability, so to speak, of the car. Anyway, continuing on. The money pit of car ownership, and it truly is. Buying a car is a huge expense. And to make matters worse, the car is going to continue to cost you money after you purchase it. It's going to cost you money. It's for the car's entire life. And then when the car is finally done, if you do keep it that long, to where it literally can't run anymore and there's nothing that can be done with it, it's still going to cost you to get rid of it, or it's either going to sit in your yard and be an eyesore. But that's beside the point. So the costs include operating expenses such as fuel, maintenance, tires, tolls, parking, and cleaning. The costs also include ownership expenses such as insurance, license fees, registration fees, taxes, and interest on loans. So if we look at the table below, it is based upon an average of 15,000 miles per year. And it's basically what this table is doing is comparing different size vehicles. So you have your type of car, your small sedan, your electric vehicle, your SUV, which is four-wheel drive in this case, your minivan, and your large sedan. And we're going to compare the cost per mile in cents versus the cost per year of each of these vehicles. Okay. Now, this is just a very basic table, and it is only based on 15,000 miles per year, and it's very broad. It's not talking about a specific brand in this particular example, but this is a very general statement just to show you the difference in the types of vehicles on a very general level. So the cost per mile for the type of car for a small sedan is 50.1 cents. An electric vehicle is 60.8 cents. A four-wheel drive SUV is 66.9 cents. A minivan is 67.3 cents. And a large sedan is 74.6 cents. Now, if we look at the cost per year of these vehicles, you can tell that the small sedan is the cheapest. Okay, it's just a small car. And it's only going to cost you about $7,516 a year versus an electric vehicle at $9,119 per year versus a four-wheel drive SUV, which is $10,036 a year, minivan $10,101 per year, and a large sedan $11,182 per year. Okay, and that's just a general based on 15,000 miles per year and some of those associated fees above, right? They're different for everywhere you live, obviously, and you know how you take care of your vehicle, what you want your vehicle to look like. But just in a sense, to give you an idea of what's cheapest to drive versus what's typically more expensive to drive. Okay. Which brings us to the cost of gasoline, which is different, like I said, anywhere, but we're going to do some general cases just so we can do some comparison. Okay. So if we look at annual fuel expense equals annual miles driven over miles per gallon times the price per gallon. Okay, pretty simple formula there. How many miles you drive versus the miles per gallon that you get on those miles driven times the price per gallon that you pay at the pump. Okay, so suppose that you drive 24,000 miles per year and gas averages $4 per gallon. What will you save in annual fuel expenses by owning a hybrid car averaging 50 miles per gallon rather than an SUV averaging 12 miles per gallon? And if you deposit your monthly fuel savings at the end of each month into an annuity that pays 7.3% compounded monthly, how much will you have saved at the end of 6 years? Okay, so let's answer question A first. Okay, so suppose that you drive 24,000 miles per year, gas averages $4 per gallon. Let's compare the annual fuel expense for a hybrid versus an SUV. Okay, so with a hybrid, we're going 24,000 miles. We're going to divide that by the 50 miles per gallon that we're going to get with the hybrid, which came directly from the problem. And we're going to multiply that times the $4 per gallon that we're paying for that gas. So if we're traveling 24,000 miles in a year and we have a hybrid, hypothetically speaking at least, we are only spending $1,920 in gas. That's our fuel expense. Versus the SUV, if it gets an average of 12 miles per gallon, I divide the 24,000 by 12, multiply that by 4, I'm spending $8,000 a year in gas in an SUV that gets 12 miles per gallon. So by owning the hybrid rather than the SUV, you're really going to save. And if I subtract those two numbers, the $8,000 minus the $1,920, I'm going to save $6,080 in annual fuel expenses by owning the hybrid and driving it rather than the SUV. That's how much I could save in fuel expenses. Okay, just going to be clear about that. Just in fuel expenses, just gasoline expenses. Hybrid might be more expensive in other areas. Who knows? All right, but let's take that and answer part B. Because we save $6,080 per year, and we're going to put it in this annuity that we talked about at the end of each month, we're basically going to have about $507 per month to put towards that annuity. That's how much money we're saving per month driving that hybrid versus driving that SUV. Okay, just because of the vast difference in the amount of miles per gallon that we are doing. Okay, so we're going to use the formula for the value of an annuity, which should look familiar here. So we're looking at P times 1 plus R over N raised to the NT minus 1 all over R divided by N. Okay, so we're making and putting $507 per month into this annuity. We're going to substitute that in. So we got 507 times 1 plus. That annuity is gaining us 7.3%. So that's where we get the 0.073 divided by 12 because we're doing it monthly, raised to the 12 times 6 because we're doing this annuity over 6 years, minus 1 divided by 0.073 divided by 12. So just plugged it in the formula. We calculate it all out using a calculator. We see that after 6 years, we have saved $45,634 using that savings with the hybrid vehicle and putting it into an annuity with a 7.3% return, okay, or interest rate. Now, this illustrates how driving a car that consumes less gas can significantly yield savings for your future. But, playing devil's advocate here, that's just based on gas, okay? That is just based on gas. That's not based on any other expenses associated with the vehicle. I'm not saying that a hybrid is going to be more expensive to maintain than an SUV or vice versa. It honestly is situation dependent, right? So just view that example as what you could potentially save with gas mileage. So what I like to look at is the gas mileage for the vehicle that the particular dealership and the brand advertises. And you know, if it is possible to take something that, a car that I do think I want to buy and find, you know, one that gets better gas mileage than another, and it seems feasible for me, that might be an option that could save you money in the future. Okay, so it's something to think about. Just something to think about. Now that ends our car section right there. Cars are important almost in the United States, especially. Most everybody has a vehicle or uses a vehicle, so it's good to know a little bit at least about how buying, leasing, and insurance and everything works with the vehicle, miles per gallon, gas prices, how that can all play into the money that you have to have available for cars and vehicles and anything associated. Like I said, it's much more complex with this, but this is just a beginner's course to give you a little bit of extra knowledge or to refresh some of the knowledge you had and help you with some of the calculations so that maybe you can more precisely gauge the situation that you're planning on getting yourself in when it comes to buying or leasing a car. I hope you have enjoyed this particular section. Please go on and try to complete the associated assignment. Email me, let me know if you have any questions. Some of these calculations can be kind of rough to do. I get that. And I know that you probably have access to a TI calculator or a calculator of some time. If you're having trouble plugging it in, just let me know. We'll work through it. No problem. But if you have any questions with this, or if you have any questions at all with the homework problems, please let me know so we can get those solved. Other than that, I will see y'all next time.